So hello friends, welcome again to my YouTube channel, and we are going to solve a new question from the linked list part, and the question title is reverse nodes in key groups. So let's understand this question. So in this question we have been given a linked list. That means we have been given the head of the linked list and we have been given an integer value k. And what this k signifies is that we have to reverse the nodes present in this linked list k number of nodes at a time. Here you can see in the example that if the k goes to 2, that means you have to take the first two nodes, reverse them, then take the next two nodes and reverse them. Here it is also given that if there is any situation where you are not able to make the set of k number of nodes, then you have to leave those nodes. So here you can see that you can do this two times, first in the first set, then in the second, and in the next one are not able to make a set of two nodes. So we'll leave it as it is. At last, we have to return the head of the modified linked list. Also, it is given that you may not alter the value in the list nodes, only nodes themselves may be changed. So here we have not been given any, we have been restricted to change the values in these nodes, and it has been given that we have to simply switch or reverse these nodes. So now let's understand how we can solve this question. So here I have taken the example 1, and this example 1 we have k equals to 2. So the k equals to 2 simply means that we have to make the pair of two nodes at a time and we have to reverse those nodes. If k equals to 3, then we will make the pair of three nodes and we reverse those three nodes. And every time if the k changes to 1, that means you have to simply reverse the one node, which doesn't mean anything. So you simply return the node. So basic point is that k is defining that how many nodes which we have to take from the starting position and we have to reverse it. And then again we have to make the same next pairs and next pairs and next pair until we are able to make a pair. Here you can see that we are able to make the first pair, second pair, and the third pair is not able to make because we do not have two nodes. The only one node is left here. So we leave it as it is. Now here the question is very simplified because in at last what we are doing is that we are first finding how many pairs are we are able to make, and at every pair we are doing a process which is reversal of a linked list, which we have done in the previous question. So my previous video is very important because the same approach is going to be applied in this question, and there is a very important insight from the linked list part. Until we have learned that there are two types of reversal in the linked list. First is a simple one where we have to reverse the complete linked list, that means head to tail. In that what we are doing is that we are taking three pointers, and using this three pointer we are simply reversing each and every connections between the nodes, and finally we are returning the tail as a head. So this is because we already know where is head and where is tail. So it is simple to return reverse all the links and simply return head as a tail. Now the next question arises in our previous video where we have a definite two points where we have to reverse the linked list. That means we have been already given that you have to reverse the linked list between first position to second position, first position to fourth position, second position to fifth position, something like that. So if it is given that it is not been completely sure that it will be from head to tail or from any point to any point, it is random. It can vary from any place. So for that we have constructed a new approach in which what we are doing is that we are reversing the linked list in phase wise order. So I would like to explain you more. So here you can see that if here in this question, if we have been given that we have to reverse the three nodes, so how we will do? So if you simply check its output, it is going to be 3, 2, 1. So this is what we need. So from that, what we have concluded that what is happening is that here we have 3, 2, here we have 2, 3, here we have 1, 2, sorry, here we have 1, 2, here we have 2, 1. So firstly, in the first approach, from head to tail approach, which is simple one, we are reversing the links. So using that same, what we have to do is that we are doing that we are first checking the two nodes, we are reversing those links, next moving to the next one, reversing that, reversing, then reverse, something like that. Now here when we are at the first two nodes, what we noticed that here 1 and 2, we have 2 and 1. So in the final output, we have 2 and 1. So what we can do is that we can first interchange this position. So after interchanging this position, what we get? We get something like 2, 1, 3, 4, and 5. So here what we have done is that we have make sure that this 2 comes before 1, because in output we have 2 before 1. After that, what we have seen, that again let's take this as a one part and let's take this as a one part. Now here the same logic is going to apply in the first approach which we have done. That here you can see that 3 comes before 2 and 1. So we will do the same. That means what we do, we move this 3 before 2 and 1. So we will get 3, 2, 1, 4, 5. So this is what we are doing in the previous question, and the same is going to be done in this question. So these are the two approach by which we are reversing the linked list. So now let's do this. So now I'm going to explain you in the simple way that how we are going to reverse the linked list in this case. So previously I've already explained in my previous video. You should check it out. And in this question, I'm also going to give you a quick look how we can do that. So what we are doing is that we are going to take a dummy node, and this dummy node is going to point to our head. And why we are taking this dummy node? Because this dummy node is going to help us to return the head pointer after a reversal of all the sets of node. So after this we are taking a pointer which is going to be a previous pointer. So this previous pointer is pointing to a position after which we have to start the reversal. So this previous pointer is always located at a position. After that, we have to start a reversal. So our reversal is going to start from our head. So our previous will be at the dummy position, which is one node previous to our head. So after that, we are declaring one pointer, a next pointer, which is going to be current pointer, and which will be pointing to our previous next. So these two are the predefined pointers which we are going to move on until the end. So after this, what we have to do is that we have to break this link. That means first in the first step, which we have explained, that what we are thinking is that we have to do it in a phase wise. So first what we have to do, if we have to reverse this 1 and 2, that means we have to make sure that 2 comes before and 1 come later. For that what we do, we have to break this link and we have to link this link to 2. So this is our idea. So for that, what we have to do is that we have to make sure that this point, this node should be preserved. For that, what we are doing is that we are going to take a pointer which is going to be temp. So don't get confused by why we are taking two pointers at the same node, current and temp. These two have the different job. You will understand in the explanation. So what we have done, that we have break this link and we have linked it to 2. After that, what we to do is that we have to link this 2 to 1, because what we need, finally we need 2, 1, 3. So this is our idea, and this is pointing to 2. So after pointing D to 2, the next step is pointing 2 to 1. So if you want to point this 2 to 1, then we have to break this. So every time when you break a link, make sure to give a name to its next neighbor node. So we are taking it as next. So this is going to be our next pointer. And after this, if we break it, what we have to do is simply link this to our temp. So we are linking this node that which is our previous next to temp. After this, when you link this 2 to 1, what we do, we have to make sure that 1 links to 3. What is 3? 3 is our next. So we can simply do current next is equals to 3. So this is the idea. So here what we have two nodes, that means k equals to 2. So what will happen if k equals to 3? For the next case, what we have done, so we have taken the next question in which k equals to 3. So here we have k equals to 3. So similarly, what we have done previously, we are going to do the same. So here we are taking a dummy node, and this dummy node is pointing to head. After that we have a pointer which is previous, and next we have a pointer which is current. So what we have been doing, so we have to break this previous link and we have to link it to 2. That means next. So idea behind is that we are going to do this in the phase wise order. First, what we need 2 linked to 1, then it is linked to 3, then 4, then 5. After that, this what we need 3 at the first position. So we will get 3, 2, 1, 4. So this is the idea, and using this idea, we are moving forward. Okay, so firstly what we are doing, we know that in the final output, this is our final output, our 2 will be always be previous to 1. So we are going to make sure that in our first iteration what will happen, that 2 comes before 1. So we have break this link and linked it to 2. After this, what we have to do is that we have to link this 2 to 1. So what we I have already told, that break this link, give it a name which is next, and point it to 1. Okay, so one thing which we have forgot, that every time we are breaking link we are naming it. So we have forgot to name it as temp, because this current is an initial pointer. It is for different purpose, but this temp and this next is for breaking and naming the next node. After this, what we have to do is that we have to point this 1 to 3. So what we will do, we will simply point this 1 to 3, which is going to be our current next, is going to be next. So after this, what we will get, you will get this loop. That means we have our dummy node, we have 2, we have 1, we have 3, we have 4. Now let's see what will happen after this. So we have achieved, we have dummy, we have 2, we have 1, we have 3, we have 4, and 5. Now, what is the outcome which we need? We need 3, 2, 1. So this is the sequence which we need. So till now what we have achieved that 2 is coming before 1. So this is satisfied. Now look what happened after the first traversal is that your previous it as D, okay, it's alright. What will happen, that you are now current it at this position, because you have appointed current equals to at the 1. So our current is at this position. Now everything is fine. So what I have told you, that this previous and current our previous initialization, so this is going to go on till the end. After that, simply what you have done in the first iteration, you are going to do the same. First, break the first link, give it a name which is temp. Now you will seeing that why we are taking a different name temp, not using current, because this current is going to move to the next node. After this, what we do, we have to make sure that this previous is pointing to which position, it is pointing to current next position. So this is important, that in the first iteration what we are doing is that we are pointing our previous to current next. After this, what we have to do, we have to point this 3 to which position, to 2, because we need next 2. So this 3 should point to 2. So we have to break this. This is our next. And what we are doing this 3 to 2. So this 3 will point to 2 like previous, next equals to 10. After this, we have to point our current to next. Here you can see that 1 should point to 4. So this is important, that this current should point to next, not to. So what we are going to do is that we will simply write current next equals to next. So after this true iteration, what will happen, that you will simply get this reverse linked list, and this is what we need. So here I have make sure to clear you that what is the purpose of this current, what is the purpose of this temp, what is the purpose of this next, and what is the purpose of this previous. So this is a 4 pointer approach, please remember it. And the simple approach, which is 3 pointer, which is used to reverse the linked list from start to till end. So these are the two approaches. Now you have understood how we are going to reverse the linked list, and only thing which we have to do is that we have to know that how many times which we have to perform this operation. So this is a simple task which we have to do, and this question is already been solved in our previous question. So let's do it and let's find out how we can do it. So let's start the coding part. So first tackle some conditions. So first condition which we are going to check is that what if k equals to 1. So if k equals to 1, so reversal doesn't matter. So we have simply written head. Next we will check if our head equals to null or our head next equals to null. So in both cases the reversal doesn't matter and we have to simply return head. Next what we have to do. So after this, we one two things which we have considered in our previous explanation. That first we need to find out that how many sets is going to be made, and at every set we have to perform the reversal. So first let's tackle out and find how many sets can be made. So I'm going to take one temp node and it is going to point to head. After this, let's run a while loop, and at every time what we'll do, we are going to write temp equals to temp next. And in this while loop what we are going to do is that we are going to count the number of nodes. For that we are going to take int count equals to 0. Every time we are going to increase our count, so c plus plus. After this we have known that how many number of nodes we have, so we can simply find out the number of packets or sets we can make. So let's take that int set equals to c by k. So this c by k is going to give us an integer value which is going to be the number of maximum number of sets which we can make. After this what we have to do is that we have to tackle the reversal of the every set. For that the steps which we have discussed in our explanation is that first we are going to create a dummy node equals to new list node. Let's give it a value 0. After this dummy will be pointing to our head. Now let's take another pointer which we are going to take, that is initially we are pointing two pointers. So first we are declaring here which is going to be our previous pointer. So this previous pointer is going to be equal to dummy. So previous is pointed to dummy initially. After this we are going to for loop, and this for loop is for the number of sets which we have. So we are going to write int I equals to 0, I less than s, I plus plus. So let's assume you have number of sets equals to 3. So how many times this for loop is going to run? So this is going to run 3 times. After this, we are going to take another pointer which is initially important, which is our current pointer. This current pointer is our previous next. So after taking this, we are going to again start a for loop, and this for loop is for reversal of that specific set. So we are going to write int j equals to 0. Our j Our j should be less than which value k, our j plus plus. So let's assume what will happen if, let's assume that we have j equals to, sorry, we have k equals to 2. So how many iteration do we need to reverse the list? So we need one traversal. If we have 3k equals to 3, that means 3 times iteration will be needed, sorry, 2 times iteration will be needed to reverse that linked list part. So what we are saying in here that we need k minus 1. So here you can see that list will going to run k times. So simply what you can do, you can write j equals to 1 to j less than k. This will ensure that this loop will run 1 times less than k. So after this what we have to do is that we have to create a temp, and this temp is going to be equals to our previous next. So why we are doing this? Because every time we are breaking a link, we have to store that. So for the first time, when we are trying to move our dummy next to value 2, we are storing this one position node in a temp variable. After this, we are moving our pointer. That means our previous next will be now pointing to our current next. After this, what we have to do now, we have linked our dummy node to our 2. Now after this we have to move our 2 to 1. So for that we need to break the 2 to 3 link. So we have to again store it. So we are storing it our next pointer, and this pointer is going to be equals to previous. next, next. So we have already linked our previous next. So previous next is going to give us the value 3, this node. After this, we have to simply point it to 1. So we will write previous next will be equals to 10. After this, the last step which we were left with is that we have to simply move your one pointer one next equals to 3. So what we will write? We will write our current next is equals to next. So what this will ensure the reversal of the first set, and after the completion of the first set, what we need to do? We need to move our previous pointer, and this previous pointer will be now moved to current. And why are moving it to current? Because we need to store our previous one node previous from where we have to start our reversal. That's why we are pointing it to current, because current will be moving throughout the loop. We have discussed with the second example where k equals to 3. Now simply we have to return dummy next. Now let's try to run this code. So this is accepted. Now let's submit this code. So this is submitted. So this is the question for today, and this is an important question because with this question you have clearly understood the importance of the reversal in the linked list, and we have already clearly understand the differences between two types of reversal. And I think that you have understood it very clearly. Please visit my previous video to understand more clearly. Now you will see the solution of both Java and Python in the same video. So stay tuned and let's meet the next video. Till then, keep learning and exploring. Thank you all.